Hey, what's up, Hognose fans? Thanks for tuning in to Hognose 1. We are going to continue our Hognose feeding talks. This one particular today is going to be called anti-predator toxins. These are something produced by a primary food source for the Western Plains hognose snake. Now, generally speaking, hognose snakes are adept to eating amphibians. If you checked out one of the latest videos, we talked about how the divergence happened from mud snakes, and that's probably the preference for certain types of amphibian prey. Now, if you have not checked out the video on nutritional epigenetics, you definitely want to check that out. I'll reference some of the things that are found there with certain, proclivities, certain preferences that are passed on from generation to generation. It's not just conditioning of a single animal like a behavior modification, but it actually goes further than that, and it translates into genes being altered for preferences of food. So definitely check out that video. But I want to talk about two different types of amphibian prey. The first one I want to talk about is the frog and toad complex, and the second one I want to talk about is the salamander complex. So in the first one, frogs and toads, and again in the Western Plains hognose snake range and even the Eastern hognose range, it's not all frogs, but it's most, if not all, toads. So there's species like the Blanchard's cricket frog that does actually secrete a toxin. I think other cricket frogs do not. I think leopard frogs do not. So again, it doesn't apply to all of them, but I will use the term frogs and toads just to give an idea of what we're talking about. But the composition of a bufotoxin is bufogen, and that's a digoxin. So digoxins are actually a poisonous cardiotonic steroid. So that just means they affect heart rate generally. So you can find it in foxglove and some other plants, maybe some fungi. But typically, this is something that is one of the main compositions for the secreted, they call it milk sometimes, that comes from the parotid gland, that big old bubble bump. It's an external bump you see usually set just behind the jawline on toads and some frogs. That is the parotid gland. So keep that in mind. That's where generally that comes from. Salamander's a little different, but we'll talk about that in a little bit. So another compound is bufotenine. That is a hallucinogen. So if you've heard of the recent, my goodness, you can hear Mike Tyson talking about it. I think Joe Rogan, some others talk about the bufotenine hallucinogenic toad milk, I guess, if you will, in the Colorado River toad. These are the ones that I think were featured on Beavis and Butthead when they talked about licking a toad's back. That is a hallucinogen. So the primary use of a hallucinogen in this sense would be to cause disorientation. Generally speaking, the predator, whatever it is, bird, coyote, whatever is taking this toad on, would spit it out, receive some dizziness, maybe blurred vision, maybe other neurofactors going on at that time, enabling the prey item to get away. It's similar to the skink breaking off a tail and distracting an animal so it can crawl away, but this particular mechanism causes disorientation. One other major component is serotonin, something you may have heard of before. It's basically a vasoconstrictor, meaning that it causes blood flow to be reduced. This could help in blood flow being reduced to the brain, maybe act alongside the hallucinogen. It also may inhibit the predator from intensified focus, going after a meal and not being able to physically exert the same type of determination to subdue the prey item. We will continue this lesson in the next video. As always, thank you for the like and subscribe, and hope to catch you on the flip side.